now here's an example of a hypothesis test for the mean using Z. We will first do it by hand and then in StatCrunch. So we know that the IQ tests are collaborated so that the population mean is 100 with a standard deviation of 15. So according to this example, the sample consists of 25 people who have mullets and the mean IQ is 87.2. Assuming alpha equals 0.05 and using the population standard deviation of 15, test whether people with mullets have a mean IQ below the general population. First, the reason this is a Z-test is that we are given the population standard deviation, and we are not told that this is actually sampling from a normal distribution, but IQ tests are normally distributed, so we'll assume it is. So we can use the Z. So, okay, so here we have two hypotheses, as always, the null hypothesis and the alternative. And this can be H1 or HA. So the alternative is people who have mullets have an average IQ below the general population. So below that's mu less than 100 because our population mean is 100. So that makes our null hypothesis just mu is equal to 100. So that's pretty simple. So now doing that, we can just plug in the numbers for the Z to get the Z. So we know that our sample mean is 87.2. 87.2, and our hypothesis value is 100. Our standard deviation is 15, and our sample size is 25. So plugging that into the calculator, so we have 87.2 minus 100 divided by 15 divided by square root 25. And that gets us negative 4.266, which you can just round it to negative 4.27. Negative 4.27. So then to get the p-value, that's going to equal the probability that Z is less than negative 4.27. And this less than comes from the hypothesis. So since we have, since we're given that mu is less than 100, we just have the less than comes right here. So that's going to equal. So we look this up on the Z table then. We're going to find a Z that is negative 4.27, the closest to that. So going to our Z table, we find a value that is negative 4.27. But here, if you notice, it says negative 3.50 and lower is 0.0001. So we're just going to use 0.0001. So equals 0.001. Okay, so that's the p-value for that. So for our conclusion then, we can say reject, like always, reject H naught. I'm just going to do it. If P is less than 0.05, since that's what our alpha is assumed, our level. So since our p-value is indeed less than 0.05, therefore we reject H naught, so reject H naught. There is sufficient evidence to conclude that mu, I'm just going to copy this, mu is less than 100. Therefore, I'll just say that means what that really means. To this problem, the people with mullets mean IQ is lower than the population mean IQ. So that's by hand. If we're asked to do it by StatCrunch, which I will simply state if I want it by hand or StatCrunch, we'll just do it. So now let's go over to StatCrunch. Here, so I'm back at where we always start. So just like the z-test and the z-intervals and the t-interval, we go to stat, z-stats, one sample with summary, and then our sample mean is 87.2. Our standard deviation was 15. Our sample size was 25. And we're testing if mu is less than 100. So this is mu. The null hypothesis mu equals 100, and then this is less than. Okay, so we push compute, and there we see our p-value. And this is what is essentially the p is less than 100 or 0.0001. And then here's our stat, z-stat. So we're going to copy this, go over to the, so I'll just put StatCrunch. So we paste it, and then you don't even need to state for if you use StatCrunch, the null hypothesis and the alternative, it's given. But I do need, you will have to state this. So first you reject H0 if P is less than 0.05, and then here's our conclusion. Reject H0. There is sufficient evidence to conclude that mu is less than 100. And that means that the people with mullets in the sample mean IQ is lower than the population mean IQ. So that's it.